Welcome everyone, and thank you so much for joining us for today's webinar, Testing When Applications Are Smarter Than We Are. My name is Brent Jenkins, Marketing Manager here at Checkpoint Technologies, and I will be your moderator. Joining me today is our presenter, Brian White, one of our senior engineers. Brian, why don't you tell the audience a little bit about yourself?
Sure, Brent, thanks. Well, I've been in the software quality assurance testing field since 1997. I've been fortunate enough to work in areas as diverse as health insurance, financial services, network security, and robotics. And I've been with Checkpoint for 4 years. That's me in a nutshell.
Great. Thanks, Brian. So a little bit about us before we get started. Checkpoint Technologies provides expert services and best-of-breed software solutions with a focus in quality assurance and software testing. We enable organizations like you to deliver higher quality applications to market faster. We started in January of 2003, and we're headquartered in sunny Tampa, Florida. We are a Hewlett-Packard Enterprise Gold Partner, authorized software support partner, and a certified training partner. We're also very proud to be partners with Atlassian, Mobile Labs, Turnkey Solutions, and Zephyr, who all make leading-edge solutions to address software challenges. We're also affiliated with QAI Worldwide. For those of you who don't know, QAI stands for Quality Assurance Institute. And if you ever need classroom, virtual, or even on-site training on things like the CSTE prep course, agile test strategies, and more, we can certainly provide that to you. As far as some of the expert services that we provide, we have staff augmentation. So if you need some strong testing resources to be part of your team, long or short term, whether on-site or remote, we can provide that to you. We also provide consulting. So anything from handling upgrades to installation configurations, test automation assessments, audits, and more. Next is our version of offshoring, where we can actually house a team for you right here in our 7,800 square foot headquarters in Tampa. We also provide education, structured classroom training, and tailored mentoring, where we actually go on-site in your environment and educate your team how to use a solution where real work actually gets done. So a little bit of housekeeping before we start. This is a live webinar, but it is being recorded. So everyone who's registered today will receive a link to that recording within 24 hours. And we will be doing a Q&A session at the end of this webinar. So feel free at any point in time, if you think of a question, you can type it into the control panel, which you'll see right here on your right. We're using GoToWebinar. So just type that question in, and we'll get to it during the Q&A session. So by the end of this webinar, you can expect to learn what a deep learning system is, some current applications around it, how deep learning systems have evolved, as well as some of the challenges of testing these systems, and our expert recommendations to do so. So with all of that said, I'm going to pass the presentation off to Brian for testing when applications are smarter than we are. Take it away, Brian.
Thank you, Brian. All right, well, before we get rolling and talking about deep learning systems, let's talk a little bit about the game of Go. As you can see from the bullets, very old game. It's a Chinese strategy game. There are 2 players. One has the white pieces, the other one has the black pieces that are referred to as stones. And the basic goal of the game is to capture as much area and as many of your opponent's stones as you can. Now, the really interesting thing about Go versus, say, the game of chess is that chess is a game where each player has, during their turn, a possible about 75 legal moves that they could make. And so a computer that is powerful enough could calculate based on a given move. Say I move my pawn up 2 spaces. A computer could calculate all of the possible moves in reaction to that move, and then could calculate the possible moves in reaction to those moves that were in reaction to my move, and could do so all the way out to the end of the game. And it could do so for each move, as long as, again, it was powerful enough and was able to run all that processing. So, the thing about Go is a 19 by 19 Go board. As you can see there, the grid has 19 by 19 squares. That in that game, there are more possible legal moves, imagine this, than there are atoms in the universe. So, the actual number of possible moves is 2.081 times 10 to the 170th power. Unlike chess, which is a game of calculation, Go ends up being a game of intuition, which, as you know, computers are traditionally, very smart, they're very fast, they're very accurate, and they're very stupid. And people, we tend to be very slow, very inaccurate, and brilliant. Deep learning systems are going to turn that on its head, and we're going to talk about that during this presentation. So, based on what we just said about the game of Go, if you were playing this game and you were black, how about it? What would your next move be? If you were the deep learning system AlphaGo, your next move would be to change everything. That little move right there, where that black piece went, when I look at it, I am no Go champion. When I look at that move, it does not strike me as being that big of a deal. It was. It changed everything, and we're going to talk about that in this presentation. But first, let's get started by talking a little bit about artificial intelligence, because you know that there could be thousands and thousands of pages and books written about the subject. We're going to shorten that a little bit. Let's start here, right? That for centuries, we've had philosophers and scientists trying to, or discussing the question of, is the mind separate from the brain, or does the brain create mind? So the brain is a physical, computational device, if you will, and it generates mind. And that's sort of where we start with the question of artificial intelligence, is with intelligence, which itself is fairly vaguely defined. Then we jump ahead, way ahead, to these two gentlemen who were sort of pioneers in the mechanical computing revolution. That is running computation with physical machines, cogs and gears and levers, and they click and they do the computation, but it is mechanical. And then, many of you may have heard of ENIAC, we move into electronic computing. And those were those giant computers that took up rooms and rooms and had vacuum tubes, and they had less processing power than a card that when you open it up plays Happy Birthday that we have today. And then we're going to jump ahead again. Now we're talking about the supercomputers. Those had parallel processing. They were incredibly powerful in terms of their ability to process quickly, tremendous amount of data, and that led to these two milestones. The Deep Blue defeated, in 1997, Garry Kasparov, who was the world champion chess player, grandmaster. And then in 2011, Watson, you may have even watched it on television, beat the two Jeopardy champions, which both were milestones, because it was computers beating human beings at games that we had invented. And then we
actually, Brian, interesting, not to jump in, but interesting to know here, the Deep Blue actually beat Garry Kasparov one game back in 1996, but Garry ended up winning the set. I guess it was the game of 6. So in 1997, it was actually when Deep Blue beat Garry for the whole entire set of a 6-game match. So I thought that was interesting that he actually beat him a year prior to that, but there we
Right,
go.
and then 1 year later, that same system ended up, they improved it enough that it could be, yeah, no, thank you, Brent. That's a great point. And so now we find ourselves looking at AlphaGo, and it beats the greatest Go champion in the world. Again, we're talking about Go, a game of intuition. Again, intuition is a term that is fairly vague, but we all hopefully know what we're talking about when we say the term. Computers don't have intuition, or do they? So what is a deep learning system? Again, this is going to be a sort of a basic appraisal or definition of a deep learning system. You could, again, read books and books on this as well, but a deep learning system is some application, some system that learns through reinforcement signals. So very similar to the way that you might, that the trainers might teach a dolphin how to jump through a hoop by giving it fish when it does what they needed to do to learn to jump through the hoop. Deep learning systems are taught how to improve their execution through reinforcement. And so the behaviorists came up with this, and they had, B.F. Skinner had his pigeon pecking on a lever, and he gets a pellet of food, and then he pecks on the lever more. That these systems learn in a very similar way. So how do they do it? Let's start by talking about the traveling salesman problem. And I don't know if you're familiar with it, so in case you're not, the traveling salesman problem works something like this. We have a salesman, and he needs to visit a group of customers, a number of customers, and then come back around to his home. But what the traveling salesman wants to know is what is the shortest path that the salesman could follow to visit each customer and then return back where he or she started. The more locations that you add, the more complex this problem gets. And it is referred to as an NP complete problem, and this is why we have the Geek Alert up there. An NP complete problem is a non-deterministic polynomial time problem. And what that means, basically, is that the solution can be quickly verified. We could look at the path and say, yeah, look, that is the shortest path that the salesman could take to visit each customer and then return home. But it might not be quickly solvable. And so the solutions can require a tremendous amount of time and energy to solve. And you can see over there on the right, the nearest neighbor heuristic algorithm is executing, and it's very similar to the traveling salesman problem. What's the shortest path to go visit your neighbors? So these systems use heuristic algorithms on neural networks to solve these problems. A heuristic algorithm is very simply, it's a trial and error algorithm. The system is going to execute some action, and then it's going to get some sort of reinforcement signal, and it will either get a successful signal or it will get a failure. And through trial and error, these systems will learn to be better at what they do. For instance, like how to get the traveling salesman to visit all of his customers and return home. Interesting point about the traveling salesman problem is that ants naturally can go and they can solve a very similar problem when they're looking for food. They're able to find the shortest path to sources of food and return back to the nest. They can do that faster than our most powerful computers today. Of course, deep learning systems are completely going to turn, make that, it's going to win, we're going to win. We're going to beat those ants going forward. But for right now, with ants, are better at it than supercomputers. Go figure. So this is a sample heuristic algorithm. And this is written, it's just a scrap of Python code. It's written by a user who refers to themselves as GDB on the OpenAI Gym, and this is part of a solution that will maximize the score for a video game called Alien-V0, which is, it's a deep learning system to improve one's score, in this case GDV score, and it's on OpenAI Gym. I'm going to show you the link to that resource towards the end of this presentation, so that if you want to go to the OpenAI Gym, you can get in there. It's an open source. It's open source, so you can go in, you can look at algorithms, you can look at the code, you can try it yourself. You can get in on the deep learning revolution. So, again, we were saying, we have these heuristic algorithms that are executing on neural networks. Neural networks, here we go, this is a basic, very basic diagram of what an artificial neural network looks like. And again, tremendous amounts of information have been documented about artificial neural networks, but in a most sort of in a basic, high-level description, they're built to mimic how our brains work. So they have a number of interconnected processing elements that they're set up in layers, and on each layer, those processing elements are connected to each other, interconnected, and the layers are interconnected so that data can be passed up and down the stack and between the different artificial neurons, if you will. And this allows for faster processing of the heuristic algorithms, which is going to be very important. So what aren't these systems? When we say, so you just saw this graphic Python code, so certainly there was programming that's involved. And certainly you want to have powerful processing, absolutely. But unlike, say, IBM Watson or Deep Blue, both of those systems were limited by their programming. And they were limited by the data that's available to them. And further, the hardware is limited by how powerful their processors are. So if you haven't written, or if, say, Watson doesn't have access to an answer in the database that it needs, it can't answer the question in Jeopardy, and it's going to lose the game, or it's going to lose that round. That deep learning systems can improve and become smarter without adding processing power or data. That you can have a system that's learning to play Go, for instance, and we could have it play today, and it's going to win a certain number of games and be beaten a certain number of games. A month from now, that same system, I have not increased processing power, I haven't done any sort of huge changes to databases or anything, that same system can learn to play Go and can now be beating the same players that were beating it a month ago. It's different than a powerfully processing system. It's a system that learns and gets better and improves its behavior. So what is AlphaGo? We're going to talk about AlphaGo because it's important to help spell out and show why deep learning is such an incredible thing. So why is it so special? We had a system, we don't actually, AlphaGo is a system that beat the best player in the world, the world champion Go player. He is possibly, Lee Sedol, maybe, is the greatest Go player ever in the history of the human race. He was 18 times world champion. That AlphaGo beat him 4-1. And in the second match, it performed what is called Move 37. Why is Move 37 so important? You can go onto Twitter. It has its own Twitter page. You can go and you can look on and go to YouTube, and you can watch it and watch that move take place. Move 37 is so important because the AlphaGo system did not have the move programmed into it. It did not have the move available to it in a database. The AlphaGo system learned to play Go better than the best player in the world, better than our best player. None of us could beat Lee Sedol. It beat him, and it did this by figuring out how to play Go. It made its own decision. Move 37 was not programmed, was not in a database. It was the decision of the system. It came up with that move by itself. That is a game changer for computers that were originally, right, traditionally, computers do what they're programmed to do, and that's it. This system made that decision and beat the world champion with it. So here are some different companies who are using deep learning systems. Google, Bank of America, Intel, Facebook, Instagram. Google uses it for its search engine, for instance, for its autonomous automobiles. Bank of America is exploring using deep learning systems for predictive data analytics. Intel is exploring using deep learning systems for design of their products. Facebook and Instagram are using, not exploring, they're actually using deep learning systems to tag photographs. So how do I find my photographs out of the billions of photographs that are there? They use deep learning systems. So this is the cool part. How do we test these systems? They are smarter than we are. They're going to surpass our level of expertise. How do you know that your results are correct? Well, you have to do it by, for instance, you've got to, if you have a system, for instance, that plays a game, you got to have it play the game, right? If that's checkers, have it play checkers. And then you need to make sure that it's playing the game correctly, right? I mean, whatever that game is, if it's Chinese checkers, if it's Monopoly, whatever, it has to be following the rules. It has to be doing what the game says it should do. And so you've got to play it. You've got to play it a lot. You've got to play it often. And you've got to challenge the game. You've got to get better players in there. You've got to exercise the system. And then you're going to want to make sure that you start out small. You can't jump in with, all right, let's have the greatest Monopoly player in the world play this game. No, you can't. You can't say, gosh, we have a data analytics system here. How about let's just load in all of our 500 billion pieces of data and we'll let it just parse it and we'll see what it gets. Because you won't know whether it's accurate or not. So start small. Again, if you're talking about data analytics, start with a small, controlled set of data. You know what the outcome should be to that particular test. Start there, and then let your system return the results that you expect. You can say, yes, it knows what it's doing. And then increase the difficulty over time. Don't jump right in. Don't go too fast. Make sure that you move up slowly. So because you're talking about a system that is going to learn to be smarter than you are, you're going to have to do a lot of exploratory testing. You're going to have to try stuff. You're going to have to check the happy path and make sure that it's doing what it's supposed to do. It's doing what you expect. You're going to start with those finite tests, and then you're going to extrapolate out. You're going to say, oh, well, gosh, it worked. You know, let's say that we're building an air traffic control system. So let's start with 2 planes and make sure that the system doesn't crash into those 2 planes. Oh, it didn't. Okay, so we can say that at least it keeps planes from crashing into each other. Let's add more planes. You can do all that. You can try executing with unbalanced input. You can say, oh, I'm gonna add X, Y this time, and then next time I'm gonna add X, Y, Z, A, B, C, D, and see what happens. You can have those reinforcement signals be off balance. Sometimes you give it more, sometimes you give it less. The behaviorists, B.F. Skinner, determined that the best reinforcement schedule for learning was the intermittent ratio schedule. That is, delivering reinforcement randomly. And so you could do that with your system to see how it learns, to see what that does. You could try executing computational refinement problems. X equals X, X squared equals X times X, X plus Y equals X, Y, and you could see where does that take you. Do you ever get a situation where your system says X equals Y? And if it does, is it right? You got to be creative. Okay, incremental testing, we've talked a little bit about this. You've got to start with a data set that you understand, especially important with data analytics. You have to know what the result should be, and then you can look and say, okay, so let's start by running a test every hour, and we know in 1 hour from now, we can see, yeah, our stock price went up, and it did. Our system predicted it would go up. Great. An hour later, it predicted it, or if the stock price dropped, our system predicted it would drop. Look, that matched. Oh, our system predicted it would go up the next hour, and it dropped. What happened there? And so you can do that. Incremental testing. Super important here. Safety requirements, right? If you are working with a safety critical system, deep learning systems lend themselves very well to agile delivery, right? So you can use tools like Jira and Confluence, Git, Bitbucket, all sorts of agile delivery tools. If, for instance, you're building a system that's going to match photographs or is going to play checkers, no one's going to die there. But if you're building that system that's going to be an air traffic control system, then you can't let that agile ideology or thing that they say, don't let the perfect be the enemy of the good. In this case, with safety critical systems, you need to make sure that they're perfect. You need to make sure that your bullet train isn't going to crash into the station at the end. You need to make sure that your autonomous driving car isn't going to smash into a bridge abutment. And so you're probably going to have to employ waterfall methodologies with gates, with quality gates, so that you're making sure before you move on to your next delivery, development, testing phase, that you know it's safe. And so make sure that you're paying attention to that safety critical system. Test automation, going to be really, really important, right? Because these systems learn through trial and error. So you have to give them a tremendous number of iterations of that test so that they can learn better. Human beings, again, we're slow. We tend to be inaccurate, even though we're brilliant. And so we can't generate 1 billion iterations of a test like test automation can. So you're going to want to make sure that you're using it to execute those tests. And then you're going to want to make sure that you are going and you're letting it generate those learning trials. You're letting it send that reinforcement signal when it needs to, and you need to have, again, billions of them. So you need automation that can run over the weekend. You're home, hanging out with the kids, and your test automation is executing. You may not right away be using the automation for validation, but use it right away for execution. Build it so it will execute against your system. And again, because it's going to be faster, because it can run constantly, and it's not going to make the mistakes. Once you debug your automation, it's not going to make a mistake. It's not going to, enter the wrong username or the wrong value or the wrong statistical analysis algorithm. It's going to do the same thing every time. That allows for consistency. That allows for speed. That allows for cleaner tests and more often, and you can control your system's learning. And again, you've got way more scenarios, way more conditions that you can validate with automation than you can do with people. People just are not going to be as fast as a computer at doing this. So you need to make sure that you make use of test automation.
So Brian, real quick to interrupt, an interesting scenario there, talking about that and using it for execution. Actually, just recently, there was a deep learning system called Libratus that was created to try to beat some of the top Texas Hold'em players. It was created by 2 Carnegie Mellon professors, and they actually, when they first launched it and they challenged humans to it, it lost every single time. But they used automation of playing it against an actual Hold'em game over the course of 2 years, it learned slowly, and it just recently, over the course of 20 days, beat 4 professional players at Texas Hold'em. So just using that to play just so many, just thousands and thousands of games, iterations of different scenarios, it learned over the course of 2 years. I thought that was very interesting.
Yeah, that is amazing, right? Getting better at us than supposedly, right? Poker is that game where you're looking at your opponent, you're judging, you're finding their tells, and no, deep learning system beat us at that too. Thanks, Brent. That is amazing. Absolutely. And so automated testing, right? It's essential. These systems are going to need it so that they can learn to get better, faster. And here, you want to start off just like you would automating any kind of testing at all. You want to automate the basic functions. You want to automate inputting usernames, IDs, or anything. You want to automate playing a game of poker. I mean, that's what you want to automate first. Are those basic functions where you know when this happens, this is the expected result. And that's where you want to start, real basic stuff. Now, again, because these systems require so much input, you're going to need to use automation to make sure that input is correct, that it's accurate, that it's consistent, that it's fast, and that it goes all the time. And then you're going to want to go ahead, not just use it to execute test iterations, but if you're talking about data analytics and doing predictive data analytics, use your automation to input data into your system. So you want to start with a system that has 100 records in it, great. And then use automation to populate 1,000, and then use automation to populate 1,000,000. Because again, the automation is faster, more accurate. It's going to do it while you're doing other things. This is kind of science fiction-y, although maybe not. That at some point we will use deep learning systems to automate testing for other deep learning systems. So you're able, right, we'll be able to take a deep learning system and have it learn how to automate testing for a system, for another system, and run validation, because the deep learning system that's automating the testing is learning while it's teaching the other deep learning system. So it can keep up with the results and with that other system. So as the system under test gets smarter, the system executing the test also gets smarter and can do a better job validating very possibly than we can, because the system gets smarter.
Yes. And actually, Google Brain has already done a variation of this by designing a deep learning system software that created another machine learning system to take a test used to benchmark software that processes language. So, I mean, Google Brain's already started that process of a deep learning system that designs another deep learning system. So it's, yeah, I thought that was great.
Yeah, it's amazing, Brent. Absolutely incredible. And so we find ourselves at a point where we have systems that are smarter than us. The importance of SMEs, subject matter experts, cannot be understated, right? You need developers, business partners, testers who understand algorithms, who understand complex statistical analysis, to understand the data, so that if you're running data analytics and your system is outputting a bunch of data, you've got business partners who can say, you know, that's right, or no, that looks totally crazy. Now, that doesn't mean that it's wrong. It just means it looks crazy and they have to go and figure it out. But you need the experts who understand your system, who understand the mathematics, who understand, because you're using incredibly complex mathematics and algorithms. You need people to understand all of that so that they can validate that your deep learning system is learning the way it should, that it's functioning the way it should, and that its results are the way it should, or the way they should be. Okay, so negative testing. We talked a little bit about this in exploratory testing, right? You're going to want to do positive and negative testing, as you do now in your exploratory testing. But remember, these are systems that are getting smarter than we are. These are systems that can beat us at poker now. So what's essential is that you understand that a negative test is indeed a negative test. Here we see on the third bullet, Move 37. If you watch, and we have a link to the 2-minute video of the commentators watching that second match and watching Move 37 happen, they thought it was a mistake because they weren't smart enough to understand. In fact, no human being was smart enough to understand Move 37. When AlphaGo made that move, Lee Sedol got up from the table, world champion, best Go player in the world, got up from the table and left. He just had to walk away. He was so blown away by that move. It was so beyond his comprehension, he had to leave. Negative tests can be like that. Don't immediately assume that what you thought was an error is an error. It might be that the system has learned something and moved beyond your or our understanding. So hopefully you picked up those key takeaways. There is a lot more research that you and all of us could do into deep learning systems. They are growing in leaps and bounds. There are a lot of companies exploring this. It is happening right now. It is very exciting stuff. But yes, and so you're gonna need to hopefully you learned about testing these systems. Hopefully you learned about how these systems are different, and testing these systems are different than even something like a supercomputer like an IBM Watson, because they learn and they get smarter. The results may move beyond our ability to understand, and so hopefully you picked up a little bit about testing them and how you can employ your expertise and your human ingenuity and innovation to continue to test these and make sure that you're using automation. You're going to need it so that you can execute all the iterations you can do, and you can input data, and you can do all that work. And keep in mind, these systems are already getting smarter than us. They're already smarter than we are. And it's not just that they're processing faster, it's that they're making decisions that are smarter than us. And so, and remember, deep learning systems, never mind, might one day be testing. Sounds to me, Brent, like they're already doing.
Yeah.
Okay, and then just real quick, these are some resources. Go check out these links. That top link is you can go watch AlphaGo make Move 37. You can see the commentators scratch their heads. OpenAI Gym, open source. You can go there. You can be part of the deep learning revolution. And then you want to go check out AlphaGo, and you want to go look at the DeepMind site and that sort of thing. The links are there. The MIT OpenCourseWare, hey, you wanted to learn about some of the mathematics? Linear algebra is very important for in terms of the algorithms that they're building. And then those last two the last two links are to tools that can be used for deep learning systems. They have libraries and that sort of thing.
And just to be clear to everybody in the audience, all of these resources will be provided in the follow-up email that will also contain a link to the recording of this webinar. So have no fear, you don't have to take frantic notes during that slide. We will be sending those out for you. So
perfect. Great,
thanks, Brian. So we actually had a few interesting questions come through during the course of the webinar. So I'm going to start out with this one because, I think it's pretty important to talk about. Can you list a few other current applications of deep learning systems?
Oh, yeah, sure. Right now, the deep learning systems are being used in things like fraud detection, email spam filtering, financial markets, doing predictive analytics, real-time ad placement. So, I know that Brent likes to go hiking. So when you open up Facebook, it sends you a link saying, hey, here's backpacks or hiking boots. So yeah, those are some. There are a lot of places.
Yeah, which those cost me quite a lot of money, by the way. Okay, great. Next question, what languages, well, I know you touched upon Python a little bit, but what languages are being used for building deep learning systems?
Oh, sure, yeah. So Python is big, and if you go to the OpenAI Gym, you'll see a lot of that is going to be Python. But they also use R, which is it's a language and environment, in fact, for statistical computing and graphics. SQL is used for deep learning systems. Java, C family languages are sometimes employed. MATLAB is an application. It does a lot of analysis of matrices and mathematical computation. So MATLAB is another tool that's used to help build deep learning systems.
Great. Thanks, Brian. Okay, so this one kind of came through right around the what aren't deep learning systems, so I thought this would apply for a little more clarification. Are the IBM machines artificial intelligence?
Yes, they are, and they're a different type of artificial intelligence, because as we were looking, that deep learning systems are a branch of machine learning that Deep Blue and Watson they're programmed, and they really are built based on their processing power. That they're not learning and they're not making decisions. They're executing programs and programmatic conditional loops or conditional statements or looping statements, and they're pulling data from databases. If the data isn't in the database, or if the function isn't programmed, then those systems can't answer the questions, can't perform the function. Whereas a deep learning system can learn to do something that it couldn't do a month ago. So hopefully that helps.
Yeah, absolutely. Okay, next question is, what skills do testers need to validate results for these applications?
Oh yeah, so you need to have everything from testers who can sit down and execute an application under test. And so they don't necessarily need to be those folks who are setting up statistical analysis of data or anything like that. They could just understand going and inputting information. You can everything from those folks to having folks who can go in and understand the programming and understand the algorithms and how you call the algorithms and how you use MATLAB to run analysis of statistics. And so you're going to need everybody, including folks who just understand your system, as well as folks who understand what the data should be doing and what you expect for results. It's a full team effort. You got to have everybody.
Yeah. Okay. Next one, what kind of automation tools can we use with deep learning systems?
Well, you could certainly, and again, like we talked about, you could totally use another deep learning system, but you could use systems like the HP UFT tool. You could use Ranorex. You could use Fitness. You could build something in-house, which is what they did. They had that system, the deep learning system, that's working with the deep learning system. I'm sure that was built in-house. And that's, that you're probably going to have different tools being used at different points. And so the developers may be doing unit testing with some tests that they've written themselves, and maybe they execute, maybe they're using Bitbucket, and they execute when they do a commit. But you can totally use a lot of the standard tools, and you're probably going to end up building your own as well.
Great. Okay, well, just to be, just to keep with the time frame here, there were a few other questions that came through, great questions. We really appreciate your engagement. We'll send the answers to all these questions along with those links and the link to the recording and the follow-up to this webinar, which will be in about 24 hours. But before we close out today, I just wanted to mention a few of Checkpoint Technologies' upcoming events. First off, we'll be at the STPCon Expo, which is in Phoenix, Arizona on March 14th through the 17th. which actually Brian today, he'll be giving a presentation titled Test Automation in a Left-Shifting World during that conference, as well as Bob Cruz, our president, will be presenting on the Internet of Things exciting impact on testing. So look for us there if you're going to be out in Phoenix. After that, we will be at QAI Quest conference in Chicago, which is April 3rd through the 7th. Once again, our president, Bob Cruz, will be presenting on the Internet of Things, as well as our Director of Client Management, Paul Shovlin, will be giving a presentation titled 10 Best Practices That Performance Testing Experts Follow. So I do want to invite the audience to reach out to us with any questions you may have or anything your organization may need assistance with. Our contact information is up here, so you can jot that down or visit our website, checkpointtech.com. I do encourage everyone here to take the short survey at the end of this webinar, letting us know how we did. We would really appreciate your feedback on that. Shouldn't take you very much time at all. So with that, on behalf of myself, Brian White, and everyone here at Checkpoint Technologies, we really hope you enjoyed our webinar, and we hope you have a great rest of your day.